A farmer has 2,400 feet of fencing to fence a rectangular horse corral and want to maximize the area, find the dimension that will maximize the area, and find the maximum area. Now, if you forgot, let me remind you, last time we talked about interest function and constraint, right? Those are easy. The hardest job is to figure out which one is which, right? Which one is my constraint, which one is my interest function. Well, you gotta read the problem, right? The problem interest in what? The area. So that gotta be your interest function, right? They want area, they will say find the area. So let me write down the area function first. What is the area of the rectangle? Rectangle. Say I'll call this X and I'll call this Y. You can call it L and W if you like. So say let X Y the width and length of the rectangle respectively. So for the area, I know the area, we're gonna call the area is A. Okay, we're gonna call the area is A. A is X times Y, the area of a rectangle is just length times width. Now the number 2,400, that's represent what? What number 2,400 represent? The perimeter, right? That's how much feet, how much fencing he's gonna wrap around the horse corral, right? So that's the perimeter. Perimeter P, I'll denote P equal. Maybe I'll use, let's see what color I use here. So I'll use black. I'll use black for perimeter. Perimeter is 2x plus 2y, right? So basically, perimeter just add up all the sides, right? X plus y plus y, so 2x plus 2y. We're gonna replace P with 2,400 because that's the total perimeter. So 2,400 equal to x plus 2y. Now, the reason we don't like the area function because right now it has two variables. We don't know how to solve two variables yet, not until calculus 2, not even calculus 1. So our job is to convert the area formula into just one variable, right? A function of one variable. Maybe I'll solve for y. It doesn't matter. You can solve for x. I don't think it matters. So I'm gonna solve for y here. So I'm gonna subtract 2x both sides here. Right? So 2,400 minus 2x equal to y. Divide both sides by 2. Divide everybody by 2. I have 1,200 minus x equal y. So that's my y. That's my y. I'm going to plug that y into the area formula. I'm gonna plug it in here. So the area is gonna be A equal x times, instead of y, it's going to be 1,200 minus x. Now we have a quadratic function. Let's distribute the x. So A equal minus x squared plus 1,200x. Is that okay? I'll write it in descending order. Now, because this is quadratic, if you grab this problem, if you grab this function right here, it's open up or open down? up and down, right? So it's like that. So that means this point right here, that's gonna be your max, right? Which is good because we want the maximizing the area, right? So that means it's implied you're gonna find the vertex. So x equal negative b over 2a. You guys remember that formula? Plug in b and you plug in a. Here b is 1200. A is -1. So I got 600. That is the width. So the maximum width is 600 feet. Let's find y. Let's find the length. All you have to do length. All you have to do is just plug in for the one that you saw up there, right? It's also 600. So let me use black again. So that's imply y equal, remember 1200 minus x right there, or 1200 minus 600 into 600. So the dimension is 600 by 600. By the way, when you maximum a quadrilateral, the maximizing shape will be the square always. The squares. We're not done yet. We're gonna find the maximized area. I'm running out of color here, and I'll use dark green. Now a equal x times y, right? So a equal. I'm sorry. Yeah, you can use that formula. So 600 times 600 is 360,000 feet. What's the unit here? Feet what? Yeah, square feet. Now, if you want to use this formula, if you want to use a equal negative x squared plus 1200x, you should have 360,000 feet square feet as well. Okay, it doesn't matter. So those are three answers they want: the dimension and the area. We're not gonna do number 12. We'll skip 12. Not gonna Yay, we finished chapter 7. Any question for number 11? It might be an important problem. You want to pick a little star there. If that was you, I'll put a star there. Lecture 8. So lecture 8, what did we do so far? We did linear function, we did absolute value function, we did quadratic function. Now we're gonna talk about polynomial in more general, right? In more general sense. So polynomial has this form. F of x equal a sub n of x to the n plus a sub n minus 1 times x to the n minus 1 all the way to a 2x squared plus a 1x to the first plus the constant. A naught is a constant. Here I added. Oh, hang on. Oh no. I meant to add a little slide here for you. Let me see if I can do it now. Yeah, I can do it now. Right there. Here, maybe it's a bigger picture you can see. So that is the general form, right? So for example, I can give you an example. Let me give you an example. Example will be, say f of x equal x to the fifth minus 4x to the 4 plus 10x cubed minus 5x squared plus 2. I'm missing an x. I'm missing an x because the coefficient of x is 0, right? I can do 0. I can put like 0x, but nobody write like that. Maybe I'll just go ahead and do like this so that you can relate to the formula. Where the first one, a n x to the n, that's your leading term. The whole thing, that's your leading term. Right? So for example, in this example, maybe I'll put 3x to the fifth. So the whole thing right here, that'll be your leading term, right? Number 3 is your leading coefficient because it's in the leading term. And then n is your leading degree, the highest degree. So far, so good? You gotta memorize this because when I say leading term, leading coefficient, you're gonna know what I'm talking about. We like to write the polynomial in descending order. There, right there. The polynomial function has the domain of all real numbers. You guys remember this when we did the domain thing? It's a very smooth function. No hole, no gap, no jump, no asymptote, no sharp corner. It's like a very continuous function. Let's determine the power function. The power function is just it's just a polynomial function with one term. Right? So the only term it has is leading term. So here is the general form. So poly means what? In Greek means many, right? Nomial means terms, so many terms. So the power function is more like a monomial, right? One term. Nothing special about it. It's just one term. If the power is even, then the graph has the general shape of the graph y equal x squared, like a U shape. If p is even, if p is odd, if power is odd, then the general graph is like a railroad track, like y equal x cubed. But we'll talk about that later. Let's determine whether each graph represents a polynomial function. Justify your answer. 1a, is it a polynomial function? Remember, what make it polynomial graph? Yeah, no break, no gap, no hole, no jump, no asymptote, nothing, right? If you put your finger in it, you should go smoothly. You should not cut your finger, right? So the first one is polynomial. Yes, right? It's smooth to me. So yes, yes, because there's because of this, because there's just this. Well, what about the second one? Is it a polynomial? It's smooth. Does it cut your finger? It's smooth, right? It's smooth. It's polynomial of degree what? 1, right? It's a linear, right? It's linear. So yes, if you put your finger there, you move up and down. It's nothing. What about the bottom left? No, right? Because what is that? Because this jump, right, gap, right? Better yet, there's a vertical asymptote there. Never cross. What about this one? Well, because sharp corner, right? I don't have to write the reasoning. You should be able to see yourself. So far, so good. That's how you identify the graph of polynomial. It's a very easygoing graph. It's really useful. Now, the behavior of polynomial function. When we talk about, let's start out with the power function first, the one with the one term. Remember what I said, if the power is even, then the graph is the U shape. Maybe I'll show you my decimal point. Right there, that is a graph of the big f of x in your note, positive 2x to the 6. And then this is the graph of negative x squared. So as you can see, it's an even power. Then we have that general U shape. Can you compare me the red one with the blue one? What can you tell around the origin? It's flatter. It's got flattened, right? It got flattened. It's got flattened around the origin, and then the graph gets steeper, right? What else? What about the end behavior? If you look at the red graph, if x approaches infinity, where does y approach to? Where does the function approach to? If I go further out to the right of the x-axis, where does my function go? Yeah, also to infinity, right? If I is same thing. If I approaches from the left, right? If like go out to the left, the function approaches positive infinity as well, right? Not so this is not the same for the blue one, the one that have a upside down U. If I approaches x from the right, the graph go down to negative infinity, right? And same thing here, I approaches x from the left, it's also go down to negative infinity. So that's end behavior. Let's write things down here. How do two graphs compare near the origin? And then you would say the f of x, the big one, the one with the 2x to the 6, is more flattened the origin. And you can guess it. If I let n get bigger, my power get bigger. Look at how flattened it is. The bigger the n, the more flattened around the origin, right? And the steeper the graph go. So that what can you conclude about the degree and the flatness near the origin? Because what we seen earlier, we say as the power increase, I'll just use a little arrow there. Graph become graphs become more flattened near the origin. And steeper away from the origin. we talk about the end behavior. If you look at the big one, does part B state what happened to y values as big F as x approaches infinity? So you can take a look at a picture there. You have to go back to decimal. As x approaches positive infinity, y approaches, maybe I'll do this, as x approaches, y approaches infinity. And the same thing when x approaches negative infinity, right? Y approaches positive infinity as well. That. Is the coefficient of the function positive or negative? Positive. That's why it opened up, right? That's why it opened up is positive. What about the graph of little f as x approaches positive infinity and x approaches negative infinity? They both go down to, yeah, negative infinity. So y approaches negative infinity. And then you can see the coefficient is negative. You gotta remember even odd function. Even function symmetric about what? About the y-axis. Right, the y-axis. If you look at these even functions, all the even functions, even degree, you can see they're symmetric about the y-axis. So they always end up at the two quadrants that kind of parallel to each other, or either here, either down here or up there. Right? Never opposite, like first and third, or second and fourth. Those are for odd. Let's take a look at the odd function. So one's like that, one's like that. I see the similar. I see the similar things, isn't it? When I have y equal negative 2x cubed, that's similar to y equal x cubed, right? Except because it's a negative coefficient, it's kind of flip over the y-axis. Where y equal 2x to the 9, what happened at the origin compared to x cubed? It's flatter too, right? It's just like flattened. As the degree get bigger and bigger, it's get more it's more flattened. So here is a demonstration right there. Degree 11, degree 13, 15. It get more flat. Right? If it degree 1, then it's just a linear, right? Straight. No curve at the origin. What about the end behavior? As x approaches infinity, yeah, mute that one. Let's talk about the red one first. The red one is the big F. At x approaches infinity, where y goes to? Infinity, right? And x approaches negative infinity, y approaches negative infinity, right? And then for the blue one, the little f, it's just the other way around, right? At x approaches negative infinity, y go to positive infinity, and x approaches positive infinity, y go to negative infinity. So it's got flip flop. So let's fill this out. We'll say it's the same, so I don't feel like writing this. You can just say, you can put the little arrow to say the same. As the degree increasing, the flatness at the origin increasing. All I have to do is replace the big G with the little g. So here is the end behavior. At x approaches infinity for the big G in positive infinity, y approaches infinity as well. At x approaches negative infinity, y approaches negative infinity. The coefficient is positive or negative? Positive. For the little one, for the little g of x, as x approaches positive infinity, the function shoot down to negative infinity. And x approaching negative infinity, the function shoot up to positive infinity. Coefficient is negative. Now, this is just perspective. I do not recommend you memorize it. A piece of advice in mathematics, if you don't have to memorize it, don't memorize it. In the past, people actually killed themselves because they couldn't just memorize too much. Okay, when you forget, it's frustrating. Just look at the picture. You can tell, right? Look at the picture. I don't care, even or odd. All that. Just give me the picture. I'll tell you what happened. Right here. You don't have it with you, but I insert it. Here is the sum up of what happened to even power and odd power. You can take a look at it, but do not memorize it. It's a good reference, but don't memorize it. Let's take a look at the graph. Y equal 2x cubed plus 4x squared. In the figure 1, that's the graph of f of x. What power function does it resemble? I know the function have odd degree and even degree. It's no longer a power function, right? It's a polynomial now. But if you look at its graph, which kind of power function it represents? The odd one or the even one? The odd one, right? It's like a railroad track. It looks like odd. It seems to me like the term 4x squared had no significance in that graph, right? I don't see a U shape there, right? So let's see what they ask. What power function does the graph resemble? Book it in here, write down the odd power function. What is the leading term of f? All right, you should be able to tell me what's the leading term of f. Very good. The whole thing, right? The whole term, 2x cubed. The leading coefficient will be 2, right? Based on the result of problem B, you know what? Do not. I say don't memorize it. So I'm gonna cross that out. What is the end behavior? You can look at the graph and you tell me. As x approaches, you always start out with x approaches infinity and x approaches negative infinity. Let's do negative infinity first and then positive infinity. So it's in that order. As x approaches negative infinity, what happened to y? Yeah, negative, right? That's why I say don't memorize. Just look at the graph. As x approaches positive, y approaches positive, right? So as you can see, it start out at the third quadrant and end up at the first quadrant. It's odd, so it's symmetric about the origin. Right? That's why you see the opposite quadrant, where even is always the two parallel quadrant. Right? So if it start here, it end up here. If it start here, it end up here. Right? Odd, if it start here, it end up. If it start in the third, end up the first. If it start up in the second, it end up in the fourth. Right? In figure 2, shows the detail of the graph of f near the origin. So here they zoom it out they zoom it out here. The scale is a 50 scale. So when they zoom it out, you see a little bit of U shape, a little bit U shape. But the overall shape is still represent the odd function, right? It's still, but at the origin have a little bit of U shape. Does the term 4x squared have a large impact for large value of x? That is on the end behavior. Basically, they're asking you, is the second term for x squared have any impact on the general graph? No, general graph, like the end behavior. Does the term for x squared have any impact on the end behavior? No, right? It's still start here, end up there, opposite quadrants, right? So overall, I'm not talking about the little picture. Overall, the second term have no impact. so it's very insignificant. So my point here for this page is basically telling you that for a polynomial function, the leading term is very significant. The rest is kind of as far as the graph concerned, the rest is have no impact on the general graph. But the first term is very significant. Leading coefficient test for n behavior. Like I said here, if you take a look at the picture, if the even degree, you can have either the graph, generally, it doesn't have to be perfect U-shape. Generally, it's like a smiley face, like a U-shape, right? If the leading coefficient is negative, then the graph is upside down U, generally, right? As you can see, the n behavior for the even graph, for both graphs, they always have the parallel quadrants. Right, parallel quadrant. As for odd degree, if the coefficient is positive, then it looks like y equal x squared, like a railroad shape in general. Right? You start out the third quadrant, end up at the first quadrant. That means it's symmetric about the origin. If leading coefficient is negative, just flip around the y-axis, right? You start at the second quadrant and end up at the fourth quadrant. Here are some examples telling you how important is the leading term. So as you can see, example number 1, my leading term is 5x to the 4th. The general shape is like a U shape, positive coefficient. For the second example, negative coefficient, it looks like a U shape upside down. And then here for the third one, 3x to the 5th, like a railroad track.
But you said that like the first term has like a significance of that, right?
Yes.
Like only like the -2 and like the 5.
No, the first term, I mean the whole thing. 5x to the 4. Leading term.
Can you explain like how that is?
So what x to the 4 look like? What the graph x to the 4 looks like? So what even power looks like? Let me go back. If you forget, you can go back. It's in the note. Somewhere here. Right here. If the power is even, your graph have the same general shape as the graph y equal x squared, well, x to the 4, x to the 6, x to the 8. It's just the U shape get flattened more rapidly origin. If the power is odd, the graph it had the general shape like an x cube, like a railroad track. Right? So go back to the example. Let me take a look at the first example. It's x to the 4, right? And then because the phi is positive, it's going to open up. Right. X to the 4 tell you the shape generally look like x squared, like a U. Same thing here. So you got the idea? Yeah. I'm not gonna say everything. You can look at the example. I don't have time to go through every little thing. So you look at the rest. Okay, you look at the rest. And because of that, because the end behavior only depend on the first term, on the leading term, we're going to take a look at the example 5a to see how the first term being calculated. So I have f of x equal -4x to the 5th times quantity of -2x minus 3 to the 4 power. Before I go there, let me give you an example. Don't write this down. If I have x plus 1 squared, you're gonna write out twice your toilet, right? For me, this is my trick. I'm gonna square the x, so x squared, and then I'm gonna square the 1. So 1 squared is still 1. And then for the middle term, it's gonna be 2 times x times 1. 3 times x times 1. So plus 2x. It's just how I do it when I do my homework. Unless the professor asks me to, show the foiling stuff, then I'll write out twice and foil it. But in general, that's how I do in my head. So as you can see, the first term is the 1 carry the highest degree. Yes. When you foil it out. Let's go back to this one right here. Negative 2x minus 3 to the 4. I'm not going to write it out full time and foil it. Why? Because the rest doesn't matter, right? The only thing matter is the first term. So all I have to do is I'm going to take the first term and full power, raise to the full power. So the first term will be negative 2x. I'm talking about the first term for that one I highlight in yellow, not the first term of the whole thing. So take that and then you raise to the full power, which is give you 16x to the 4. And then now I'm plugging it back. Instead of using the whole complicated negative 2x minus 3 to the 4 function, I'm going to use the new one because I only care about the first term. Right? And then I multiply with the rest. Now I got negative 64x to the 9. That's my first term of f. Right? Of course, that's the rest. There's plus, blah, 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 which is not really important. Right? Can you determine your graph by looking at the first or leading term? Yes, right. It's the railroad one. It have odd power. It have odd power. It look like a railroad track, and because the coefficient is negative, you're gonna flip over the y-axis, so it look like that. Right. This is not true, but just in general, it looks like this. In general, it looks like that. Right? When x approaches negative infinity, y approaches positive infinity. When x approaches positive infinity, y approaches negative infinity.
Why is negative 4 with not our leading?
The leading coefficient, by the way, is this in general form yet? Not, right? Not in general form yet. What general form? General form is f of x equal an x to the n plus an minus 1 x to the n minus 1 all the way to x squared plus ax plus a naught. This is not in the general form. It have two factors here. So you in reality you write the yellow part out 4 times and you foil it. But it's not practical here for us, right? Because we only care about the leading term.
So if we like a factor, then that's going to be our leading.
If you want to factor it out,
So why isn't negative 4 to the x bit our leading term?
it's not leading term.
Why?
Because it's not the general form. Look at the general form I wrote. The leading term add to another term. Do you see addition between the two things? No, that's multiplication. So you have to foil it out. Let me ask you this one. Don't worry about that one. F of x equal x times x plus 1. It is in general form? No, right? General form would be what? X squared plus x, right? In general form, you can have one term plus or minus, depending on the coefficient, plus another term. For the first one right here, do you see plus? No, you see multiplication, right? You see two factors. So basically, this is one term right here. It's okay. Everybody has different rate of learning. I understand that. And I cannot please everybody at the same time. I try my best. Right? I have office hours. You're very welcome to go ask me questions. But don't feel frustrated because you understand. I felt the same when I took some classes. Right? I experienced everything. Your U try would be B, U try 1. Today 27. By the way, U try 2 is already embedded in the question, so I don't have to write it out. Your U try 1 asks you what is the leading term. So you do the same thing like 5A.
Okay, so for B, what our leading term is then 2x minus 3 to the third.
And then you multiply to the first one. And you multiply to this one. Look at the example A, it's the exactly same thing. And if you have questions, you can come to my office hours. I'll even show you how to do it. Any more questions? I know this class is fast paced. It's my compared to 61, 62. Right? Objective 3. We're gonna talk about local behavior of polynomial function. What I'm trying to do, what I'm leading you here. I'm herding you toward how to graph a function, a polynomial function. So the little baby step. These are little baby steps. If you have a hard time picture the whole thing, do not worry. You see at the end. If P is a polynomial function in the form, again, that general form, with the leading degree n, there is at most n x intercepts. What does that mean, nx, at most n x intercepts? Well, according to fundamental theorem of algebra, the number of the degree corresponds to the number of your solution, right? If it's quadratic, you should have 2 solutions. Cubic, you have 3 solutions. Quartic, you have 4 solutions, and etc. Right? That's why linear, you only have 1 solution. So x-intercept is your solution, right? That's your solution. So it corresponds to the highest power. There is only one y-intercept, which makes sense, right? It's a polynomial function. It's always cut the vertical y-axis at one point. Sometimes it doesn't cut it, but at most 1 point. There are at most n-1 turning point. Turning point where the function increasing or decrease, starting to increase and decrease, or vice versa. So those are turning points. I think I have a picture. Right there. I think I do have a picture. So turning point are those local max and local min. Your x-intercept is where the function touches the x-axis. It's a challenging lecture today. I'm not gonna lie. Let's take a look at 6a. If you look at the picture on the right, is the degree even or odd? Even, because that general U shape. If you kind of see the whole picture now, slowly. Is the leading coefficient positive or negative? Negative, because it's open down. Right? Find the number of x-intercepts. How many do you see? 4, right? 4. This picture is pretty straightforward. Find the number of turning points. 3, which makes sense, right? Turning point n-1, so 4 minus 1 is 3. What is the minimum degree of the polynomial? Remember, n is your leading degree. N is 4, so the minimum degree of polynomial should be x to the 4, right? That's minimum. That's minimum. And I'll explain to you why. Maybe I should write number 4. Why is not called maximum? So far, so good for problem 6. Number 7. Is the degree even or odd? Odd. Is the leading coefficient positive or negative? Positive, right? It looks like an x cubed, so positive. Find the number of x-intercepts. 1, 2, 3, right? You see 3. You see 3. Don't write too hard. Just write lightly. Find the number of turning points. 1, 2, 3, 4. Right? Oh, something contradicted. Remember, the turning point is n minus 1. But in this case, the turning point is larger than the x-intercept. So we're gonna fix the x-intercept. The x-intercept should be what? 5, right? Why is that? Huh? Very good, right? Let me ask you a question. So the minimum degree will be 5, minimum. Right? Let me ask you a question. Don't write this down. Just watch. If I ask you to solve x minus 1 squared equals 0, what do? You square both sides, right? Plus minus. So on the left-hand side, x minus 1 equal, well, plus minus square of 0 is still 0. And then you solve, so x equal 1. Now, this is, you start out at the quadratic. How come you only have one solution? You've been taught have 2 solutions. And then you graph this. You don't believe yourself. You graph this. Just gonna move to the right 1 unit, right? So it looks like that. And again, you only see one x-intercept. Well, because what? Because x equal 1 is a double root, right? X equal 1, x equal 1. Right? So the x-intercept, that graph cut the x-intercept at 1 twice. At the same place, so you don't see it. So the picture could be deceiving. For me, I know this one is for me, for the one that being bounced off, the one that kind of turn around, you could have double root, you could have 4 root here, 6 root, etc. Like even number of roots. Depend how flattened the graph around that point. Can you compare the two local minimum here? This one look like skinnier, right? Look, this one a little bit fatter. I know the scale is difficult to see, but for me, maybe I'll see this one is the x squared. This one will be the x to the 4. Right? It's flat around that point. You get it. Do not worry. Let me write out some tips for you. Maybe it'll help you when you graph it. If the graph bounce off, or in the note they call that turnaround, if the graph bounce off, then the multiplicity, do not worry if you don't understand. You will soon. The multiplicity will be 2, 4, 6, 8, etc. And how do I know if the 2 is a 4 or the 6 or the 8? Well, you look at the picture. It depends on how flattened the graph around that bounce off point. If the graph goes through, meaning it crossed the x-axis, excuse my language, I don't have enough space on like that. Then the multiplicity it's gonna be odd. It's gonna be either 1, 3, 5, or 7 or 9. And again, that's depend on how flattened. Same thing, depend, like a picture I showed you in the beginning. On how flattened the graph around that point. If you don't understand, do not worry, you will soon. I'm preparing you for the next objective, objective 4. Multiplicity, sound fancy? Oh, I'll explain to you what multiplicity means. Multiplicity is the number of times the graph touches the x-axis at a point. So for example, at x equal 2, the multiplicity 1, because the graph is really, really steep, it looks like a linear, isn't it? There's no curve around 2, right? So it's gonna be, and because go through, it's gonna be odd, either 1, 3, 5. In this case, it's gonna be 1 because it's so steep. It looks like a linear function. Where at x equal -1, it have that little curve. That little curve mean it's gonna start at least the third, at least the cube one. So multiplicity is the number of times the graph intersect the x-axis at a point. That will be corresponding to the power of each factors, and I'll tell you what are the factors are. If you take a look at example, the figure 3, each factor that correspond to each x-intercept, or we call that zeros. So let me write them down here. I see x equal -1, x equal 1, and x equal 2. So those are your x-intercepts. I want to make the right-hand side 0. Can I add 1 both sides? For the first equation, you add 1 both sides, you get what? X plus 1 equals 0. You subtract 1 both sides in the second one, so you have x minus 1 equals 0. You add 2, x plus 2 equals 0. Those are your factors. X plus 1, x minus 1, x plus 2, those are your factors. And then you write them together. Now your next job is going to determine the multiplicity or the power of each factors. So that's what multiplicity means. Right. Like I said, if you take a look at x equal 2, it resembles the linear function, right? So the multiplicity is going to be to the first power, which we don't usually write. For x equal 1, it's a bounce off. It's bounce off or turn around. So you better have either square to the 4 or to the 6. It looks like a parabola. It's not much of a flatten around it, right? So it's gonna have a multiplicity of 2. So x minus 1, all of that square. And then if you look at the last one, x equal -1. X equal -1. It looks like, again, it's cross of the odd multiplicity. In this case, it's going to be the cube. Can't be linear because not straight. Yes.
The graph always gonna go this way. Like when you put it into the, like the f of x. Like you know how it says x minus 2. Why isn't that x plus 1 first?
I don't get it.
Like, okay, so your intercepts, your x-intercepts, how come the 2, 1 is first and not the -1 on the graph?
Oh, it doesn't matter.
It does.
It doesn't matter. I can write. Usually I go from left to right. That's my habit. In here they write it in according to how they explain it here.
Okay.
Doesn't matter.
So it doesn't-
No, doesn't matter. You can start with this one first. Start this one first.
but
Yeah.
the answer will be the same.
Same.
When you were writing your x-intercepts,
Mhm.
isn't the x-intercept x equals 2, not -2?
Yes. X equals 2. Sorry. Yeah. Thank you very much. I was thinking ahead of myself. So x minus 2. I was thinking ahead of myself. X minus 2. It's better for you to see from far away than me up close here. So if I do something wrong, fix me right away. Okay. I don't want to get recorded and get it wrong. Take practice. I don't get it the first time when my prof taught me either. I went home, I read the book, I watched some video, do homework, and then I kind of get it. Let's take a look at this one. Number 9. the polynomial below have x-intercept at x equal -2, -1, and 1. So when you move everything to the left, so you add 2, you got x plus 2, you add 1, you get x plus 1, and then you subtract 1, you get x minus 1. Now your job is to determine the multiplicity of each of the factors. Let's do the one first, the easy one. Let me write it down here. Right, let's do the easy one first. You don't have to go from left to right. Let's do the easy one for this one at 1. So it's correspond to x minus 1. I write from left to right. 2, -2, -1, and 1. Okay. So let's do this one first. What degree you're gonna think it would be? It's go through, so it's gonna be odd. 1, 3, 5, 7, etc. Can't be 1, can it? No, it's not straight, right? 3, right? It looked like a 3 to me. It's not too flat, right? It looked like a 3 to me. Do you have so far so good? It's like a railroad track. It's odd, yeah. It's
Like, what if we say like 5?
if it's not as too flat. Yeah, it's not too flat. But I get you, because sometimes because of the scale, you're not wrong. Some people can argue 5 and they make it right. Right? It's possible. Right? It's possible, bro. But it's not flat, so I'm gonna assume it's 3. What about at -1 compared to -1 and -2? Which one more flat?
2.
Flat. 1, right? So it's gonna be even power because it's bounced off. So the first at -2 is gonna be square, right? And this one gotta be just a 4. So the smallest even multiplicity is a square. And at -2, it looks like a skinniest one, so it's gonna start out at 2, and then the second one is got a little flatter, so it go up. So the 4. So that's your reasoning. Why don't you guys try B? Now, let me go back to figure A. Your overall graph, does it look like an odd degree or even degree? Odd. If you add up all these, x squared, x to the 4, x cubed, you got x to the 9, right? So it's kind of makes sense. You know that it's not 100% sure, but you kind of feel more confident. And then let's do it -2. Again, because I see -2 is only one time bounce off, nothing I can compare to, so I always start like that. What do you think? Is it square? Yeah, that's square. What about at -1 and 1? Look at the difference. It's gotta be odd, right? Because it goes through, it cross. At -1, you think it's linear? Yeah, it's linear. There's no curve, so it can't be cubed, right? If it's straight like that, it's gonna be linear. So to the first power, which maybe I'll write to the first power there. What about -1? It looks like a cube, right? Cube. Let's add up all the x squared, x to the first, x cubed. 2 plus 1 plus 3, that's 6. And your overall shape is look like a U shape, right? That makes sense. It's not fun for me to see you struggling. Trust me. If anything, it make my teaching even more challenging. Number 11, find the possible function. That's what they call possible function. It's similar to number 10, but I'm gonna go straight to number 11. You think it's gonna be odd function or even function? It'll be odd, right? It'll be odd. So let's write out the x-intercept first. So I see x equal -8. I see x equal -2. X equal 1. And then you move everybody to the left. I have x plus 8 equals 0, x plus 2 equals 0, x minus 1 equals 0. And then you put them together. X plus 8, x plus 2 times x minus 1. At x equal -8, is it linear or? It looked like a linear to me, right? It looked like there's no curve that's -8. So straight, so it looked like linear. So to the first power.
Is that supposed to be 3?
What is talking?
I think it's 3 and not 8.
Oh, -2. Oh, sorry. I didn't see. Thank you. Thank you very much. The graph crossed it. At x plus 2, at x equal -2, what do you think? Is it odd? Is either 1, 3, or 5? It looks to me between 1 and 3. But what do you think? What do you think? It's a 1, right? It's straight. There's no curve, so it's got to be a 1. What about at x equal 1? 3? Yeah, it looks like a 3. You add up all the degree. That's 5th degree. Makes sense, right? It's the odd function, and you're not done yet. You're gonna figure out your a, right? The scale, how stretched is your graph is, or how compressed. They give you that point. They don't give you that point for no reason. For you to plug it in. So that's your x, that's your y, right? You're gonna plug it in. So what did you get? 3 for y, and then 2 for x. Two plus 3 is 5. 2 plus 2 is 4. And 2 minus 1 is 1. It's cube. 1 cube is still 1. 5 times 4 is 20. So 20a equal 3. A equal 3 over 20. So your final function is 3 over 20. X plus 3. X plus 2. X minus 1 cube. Let me do last one, and then we'll call that a day. Number 14. Find the equation of the polynomial function given the following. So they want you to find the function, given some information. The polynomial is of degree 5. 0 multiplicity 2 at x equal 1. X equal 3, and so x minus 1 equals 0. X minus 3 equals 0. You put them together. Of course, there's an a there. You don't know. You're gonna write a. Multiplicity at x equal 1 is 2, so it's gonna be x minus 1 square. Right. The triple 0 at x equal 3, so it's gonna be a cube there. Now you solve for a. Well, they give you x and y here. Plug it in. So 15 equal a times 2 minus 1 square, 2 minus 3 cube. Let me give you happy ending because we run out of time. Your final answer is, your final A will be A equal negative 15. Okay, done. If you have something like this on the exam, can you do it? Is it you like this or you want the one that you have to guess? Yes. Yeah, you try to, it's in there. It's in the question.
Is it possible?
Oh, is it you send me the accommodation?
Possibly. Could I get like extra, like a copy of your notes sent?
Yes, I post on Moodle.
Okay.
Yeah, I always post on Moodle.
Also, I missed a drill on Wednesday because I live all the way in Chesterfield and the snow came really down.
You mean the you try?
No, the drill.
Oh, you have to talk to the bookshop.
Okay, okay.
What's your name again? I gotta write down.
Rachel.
I know this in the email. Are you the one sending that 1.5 times?
What?
Oh, you're not the student. You're not the access student, aren't you? No.
No, I keep forgetting to send you my accommodation letter.
Oh, okay. I know there's a student sent me. I thought it was you.
Oh, okay. I'm
So you haven't sent it yet.
No, I keep forgetting because I just haven't.
Okay, just please send it to me.
All right, I should send it this afternoon.
Okay, yeah.
I just want to check if it's right.
So you only care about the first term? Don't need that.
Yes, I mean, that's the final answer, right? Thank you.
I don't know the answer, but the first term. Assume that your calculation is right. It looks right. It looks right.